Hey everyone, back with another acquisition. This one's not from this group trip. I got this last year but did not have a remote for it. This is a Fanimation Kute, and I was always curious about one because I've seen how they perform. I've seen review videos from a couple other fan collector friends. I know one from Cole Semenko gave a great review on it. Chandru also gave a great review. Seemed to like this one. I got real curious about it and was able to get one. I was hooked up at Fanimation with it last year's group meet, and but unfortunately last year I did not have a remote for it. It just was not in the box. So just it's been a while. I was able to get a remote for it. I asked them and they had one. So as you can see, I unplugged. I'm not even using the test rig on this video because this is a DC fan. I can only use the specific remote that it came with, or it would be included. So I'm going to plug it in like applying power. So I'm going to start with the light. This is the light. I chose to assemble this with the light to show it because there's a switch cap in there that I can, mount this or use this without the light if I wanted to. But I want to use this with the light. So this light has a dimmer on it. See what it... Okay, that's as dim as it gets. See, that's only drawing 0.04 amps, about 3 watts, half a power factor. I'm going to go back up on it, holding down the remote. And so I'm drawing 0.14 amps, 16 watts, at a power factor of 1. But this, of course, is an LED light. The thing with a DC fan is it's like having an LED light, but with a motor. I mean, you have your traditional AC powered motors, just like you have your traditional light bulbs, but this one is got circuitry to rectify the current. The receiver has the circuitry in it to rectify, to run this fan on DC current instead of AC current. So then it draws way less amps than what it would draw for this size of fan on typical AC. So right now it's drawing a little current just like Casablanca's IntelliTouch. When you turn the power on, it draws like that much current, just a little bit of current going through it. It's basically reading the current in the receiver because there's AC power applied to it. So what you can do is you can hook this up to your regular light switch, but then, you can use that as your power kill switch if you had to, but you can leave the light switch on if you want. But then, use the remote. So here, to turn it on, this is the lowest speed setting, and it's not really drawing any current, more current than just the fan being off. So almost 2 watts, less than half of a power factor. Now I'm gonna read the tachometer to give the speed range. Here is the tachometer. Okay. I'm gonna go with 88 or so. I got an 88. It's a little all over the place. So I'm gonna go 88, and I'm gonna divide that by 3 blades, and I'm getting just shy of 30 RPM. So that's what I'm getting right now. This is the lowest speed that it has. So I did watts and power factor. So I'm going to kick it up a speed. So when I do change the speed or turn it on, it goes to high. That was speed 2. Goes to high first to accelerate it. It likes to prevent stalling out from happening. And that's just what DC fans do. They also jerk a little. They kind of have a sudden start to them instead of just a wind up. I'll tack this one just because this is a more typical low speed. 146, 145. I'll go with 145. This is a more typical fan low speed for a fan like this. So 145 divided by 3 blades. And you got just shy of 50 RPM. So this is a low that everyone expects. You got kind of that almost aesthetic. This is speed 3. I think I'm gonna 2 watts, still a little higher power factor. It's pretty much right at half. Let's see, I'm gonna tack this one. I'm already feeling air off it. 204, I'm just gonna go with 204. 204 divided by 3, 68 RPM. This is speed 4. And it's almost drawing 1/10 of an amp. And I'm already in the medium speed range. 4 watts, half a power factor. Let's tack this. Did I do this one? Nope, no I didn't. Yeah, 260. I'm gonna go with 260 divided by 3. That's 86. We'll say, yeah, 86 RPM. So getting close to 100. Next speed up. I think this is speed 5. I lost track. Yeah, the current draw only went up a little bit. Still 7 watts. Just over half a power factor. Let's 320. Let's go with 320. Divided by 3. Okay, so we're a little over 100. It reads 106 RPM right now. Revolutions per minute, that is. Kicked it up, next speed. And I'm really feeling air off it already, because this is actually quite a steeply pitched bladed fan here. So I'm really feeling air for the speed that this is only going at. 378. We'll go with 380. I'll go with 380 on this one. 126 RPM. So I'm almost to high. 0.22. So this current draw here of 0.25 amps, this is a quarter of an amp going now, is what most fans typically would draw on low. 17 watts, almost 18 watts, and little more than half of a power factor. Let's tack this one out. 437. It's like it kind of goes a little all over the place. Really feeling air. We'll go 434, 435. Divided by 2. Oops. 435. Nope, divided by 3. And I'm getting 145 RPM. I think this is high based on the indicator here. It's hard to really show. It kind of halos out a little. Now this is almost like a typical medium speed, maybe a medium high with most fans. But this is really kicking off a lot of air. So let's see, so 0.46 amps. So this is high speed, and this is a common amperage draw for a medium speed fan. 31 watts, and still only half the power, just a little over half the power factor. So now I'm going to use the tachometer again. I'm going to tack this out. 519, 523. Let's go with 524. Okay, so 524. Now this one, I read the specs, and it looks like, according to the specs sheet on here on Amazon and even on Fanimation's specs form, this says it's known to mainly go 171 RPM. So 524 divided by 3. Yep, about pretty much 175 RPM. So not quite 200 RPM as most fans would do. Most residentials tend to go maybe a little over 200 RPM, around 200. This is close to 200 RPM, but not quite. But I'm really feeling air, almost like an industrial, almost the air of a gold line. Maybe not a gold line, but this is a lot of air for this type of fan. Okay, now I'm going to use the anemometer here, and I'm going to attempt, I'm going to see what the CFM is. I thought it read around like 5,000 in the specs sheet, maybe 4,000 some. So I'm going to see what I actually get. 590. Okay, I am getting 590. Now we have a chart here where that was calculated of diameter of fan sizes by the surface area, and we're basically translating that to cubic feet a minute. So they gave like something like almost a 5,000 CFM. Let's see what my test gets, because this is a rough test. This is just an idea. So I got 590 times, 52 inches, 14.75. Well, this is telling me 8,000, but yeah, there's some things they do, all sorts of tests. They take an average in all sorts of different environments. So, but this does feel kind of almost like a K55 blender fan. I mean, so I know the K55 blender fans out there are a little faster than this, and in the almost pretty much at 200 RPM, but yeah, this one. So in this case, time for what's called spin down. Let's see how this thing spins down. Okay, well, so this thing has got like a timer. You can set, like, say for a run for an hour, run for 3 hours, run for 6 hours on here. It's got some interesting features. I'm not sure, the home button. Maybe, yeah, I'd have to read up on this a little bit more, but on what these mean. But the bottom, this is the reversing. So right now the picture of the sun is to symbolize summer, so which means it's going the direction that you saw it go. Now if I hit the snowflake button, now I'm gonna hit low. Yeah, and you can see that it's now in reverse, and it's drawing the same current because this is a DC fan. I just want to show that pretty much is drawing the same current. I'm going to speed it up. So I'm curious. I'm going to put my hand above and see. Okay, it is moving some air. It's moving air because some of these fans, some of these unique blade-shaped fans do not move air in reverse because they were not designed to run in reverse. But I am seeing some air actually moving, but then again, it's not quite the same air movement as the other direction because the blades do tend to point upward to span out, so that is the intention. But fan companies have been putting reverse on every fan for quite a while now. Whether the fan is meant to run in reverse or not, it's just that whole standard feature. Which I was told it was a gimmick or kind of a marketing idea to sell fans year-round by putting reverse and advertising it as the idea of spreading your heat around with the reverse air, with the air going up, pulling it up so that you can spread the heat indirectly down the sides. So you would really run it on low in reverse. So I could actually hit the sun again, the sun icon, and it's going to go in reverse. So it's got to stop first. You can see the blades kind of point a little up, kind of an up and out, kind of like a new fan or view fan or a CEC industrial. I kind of noticed, so there is a little bit of an upward span, so it doesn't quite move as much air in reverse as this direction, downward air. Okay, so one last thing I want to see is show. I'm curious to see if it's got any inrush at all. So I'm doing 0 to high. So current draw climbs, so there's no inrush. Basic, but yeah, CFM, I'm calculating that surface area that we found, converted from inches to feet. It's like, I can't remember, Dan did the formula, so, and then I multiply that by the anemometer's wind speed that I'm getting with the fan when I hold it up to it to give an idea on it. Okay, well that's actually all I have for this Fanimation Kute. So I'll be back with more fans later on, because I know I got a couple of other acquisitions to do. So I'll be back with more fans. But before I go, I gotta thank my sponsors like Dan, just because the first sponsor I'm going to sponsor is... watch the fans. Whoa. PowerMate. Buy PowerMate for canister vacs. Buy PowerMate. When one motor isn't enough, you need 2 motors for vacuuming. The PowerMate Canister Vac Company. And, of course, by Jonas Organs and Doorbells, because they are marvelous and magnificent. And, of course, I also love sponsoring Reese's Pizza. Be sure to eat your pizza. And by My Kid's Obsession, which teaches you that it's okay for your kid to have such an interest, such as fans and vacuums, and not to be shameful or embarrassed about it. But I also want to introduce, since I picked up on Sperry, the best beverage choice of fan collectors. So that's all I have for this Fanimation Kute. So it's very good. I'm scatterbrained today. So keep watching and subscribing.